Hey everyone, Professor Sebastian. Welcome back to Statistics Class Notes. We're in section 6.1, talking about probability distributions, and we're at the bottom of page 77 here in example 101. Consider the random variable x such that x equals the number of stars given by a randomly selected book reviewer on Amazon. So that's a situation where you get 1 star if the book is bad, 2 if it's a little better, 3 if it's neutral, 4 if it's pretty good, and 5 if it's excellent. Okay, so with some research, the top of the following page is an example of what the probability distribution graph for this random variable could look like. So this is a graph. This is a spike graph, or just a probability distribution graph for what's called a discrete random variable. Again, I haven't defined that, but it's essentially a random variable where it is possible to list all the outcomes. So all the outcomes here are just 1, 2, 3, 4, or 5. So in other words, the number of stars that anybody could get for a book is either 1, 2, 3, 4, or 5. And then the probabilities are listed on the y-axis, and you can kind of get fairly close to seeing what those probabilities are by just going across and reading them. And again, these all would have to sum up to 1, so we may read them slightly different and be a little bit off, but since we don't have the list of them, we just have to do our best on the table. So let's estimate the probability that a randomly selected book reviewer gave a given book a 3-star rating. So what that's asking for is what's the probability that x equals 3? So you may read it slightly different, and that would be okay, but I'm reading this as approximately 0.11, or about 11% chance that the book reviewer got a 3-star rating. So this next problem actually comes straight out of your homework. We've had so much trouble with it in semesters past that I decided to add it to the notes. So let's talk about this problem, example 102. When a certain type of thumbtack is tossed, the probability that it lands tip up, so you imagine a thumbtack tip up means that the tip is not lying down touching the table. That's 75%, or 0.75. And the probability that it lands tip down, the thumbtack lands tip down, is 25%, or 0.25. So let's let U mean the tip is up, D means the tip is down. So the list of all possible outcomes when 2 thumbtacks are tossed is the following. So the first thumbtack could be up, and then the second one could be up. Or first thumbtack could be up, second one down. Or first thumbtack could be down, and the second one up. And the last possibility is that the first thumbtack is down and the second one is also down. Now, are tossing these thumbtacks independent of one another? So hopefully your intuition tells you yes. Just because a thumbtack lands tip up or tip down in any single throw it up in the air, it doesn't mean that it has a better chance to land on tip up or tip down the next time around. So they're independent of each other. That means they don't have any effect on each other, the individual tosses of the thumbtack. So let's complete the following table. So what's the probability of getting up on the first and then up on the second toss? Well, notice I said up and up. So this is up and up. It's an and situation where we know we need to use the multiplication rule, and since they're independent, we just multiply the probabilities. So 3/4 times 3/4, right? That's 0.75. I'm putting them in fractions, easier to multiply. 3/4 times 3/4 is 9/16. So the probability of getting up and down, right? Up on the first toss and down on the second toss is going to be 3/4 for the up times 1/4, right? 0.25, 25%, 1/4 for the down. So that's 3/16. Probability of getting down and then up is 1/4 for the down, and then multiply that times 3/4 for the up and get 3/16 again. And then the probability of getting down and then down is 1/4 times 1/4, which is 1/16, and notice that these do sum to 1. So the problem said, let's let x equal the number of thumbtacks that land tip up out of 2 tosses. And let's complete the following probability distribution. So what are the possible outcomes for x? Remember, x is the number of thumbtacks that land tip up out of the 2 tosses. Okay, so x could either be 0, that means you get no thumbtacks landing tip up. It could be 1, where you get one of the 2 landing tip up, or it could be 2, where you get both of them landing tip up. So what are the probabilities? The probabilities for 0, for x equaling 0, well, that's the situation of this guy, probability of down and then down, which we computed to be 1/16. What's the probability that x equals 1? So this is 1. Now notice that both of these are having one thumbtack land tip up. So you add those two together. So you get 6/16 or 3/8. And then the probability that you get both of them landing tip up is this guy, probability of up and up. So that's 9/16. So again, those sums add up to 1.